Okay, what we are moving into, the idea of running loops is the most complicated thing we will cover in this class. I think it's conceptually really difficult to understand, and it's also much more complicated syntax than what we've been doing before. So it is imperative that you stop and ask when you don't understand something, because this whole section of the workshop won't be useful if you're not clear on what the fundamentals of what we're trying to do are. So a loop is it's a very useful tool to be able to repeat a set of code again and again and again to different parts of your data, for example. There's some process that you're trying to do. You're either trying to generate or change data, you're trying to calculate a statistic, you're trying to match rows of a data set together. There's something going on that you're trying to do. It's the same process over and over and over again, but you want to change the conditions slightly or apply the process to some different part of your data. And so instead of just cutting and pasting the same line of code over and over and over again, if you put that line of code within a loop and include a condition that lets R know when it should keep running through that loop and when it should stop running through that loop, it's a much more efficient way to get the process done. So computer scientists in the room probably would have more to say about what the loops are, what the functions of loops are. So if you have questions, I'll point you to Emily or Zach to get a little more detail about. And Yost, I don't know if you've done loops in any of your courses. Yeah. Okay, so the three of them are your relative loop experts. One thing I do know is that loops are not necessarily the most efficient way to do what you want to do in R. So if you find that you're starting to work with really big data sets or trying to get R to do something that's fairly computationally intensive, you can essentially, the program can just crash essentially while trying to go through loops. I've discovered this the hard way too many times. And I'll talk about one of the things you can do to help you know whether or not your loop is continuing to run and it's just taking a really long time to get through it, or whether R is just throwing his hands up in the air and giving up on you. So we're going to walk through a really simple, straightforward example. And then we will apply what's going on in that example to a slightly more complicated situation. So in this example, I want to know the square root of the numbers 1 through 10. So the time-consuming, annoying way to do it would just be to use the square root command, sqrt, open parentheses, and just type it over and over again. Get square root of 1, get square root of 2, get square root of 3. But if you, since we're trying to do the same process over and over and over again, we can write a loop around that, and so that R will continue to do that automatically. So we're going to tell R to iterate through this calculation, and we're going to use an index variable. We're going to create an object, or we're going to create an index I, where this I takes on a different value every time we go through the loop. And we're going to tell R, we want to go through this loop when I takes on the values 1 through the value of 10. So the basic loop syntax, you'll see on there, there are other ways to do it, but in this example, we're going to use the for command. So it's for, open parenthesis, close parenthesis. And then what you want to actually be looping over is inside these two squiggly brackets. So we'll start in the inside of the loop and work out. Okay, so notice that our command right here, this is the command that if we wanted to do this by hand is what we would write. So the square root of I. And I is the thing that we're going to have change through every walk of this loop. So I is what's going to take on a different value. So we want the square root of I, whatever I is in that loop. But when R is doing something, when you're not typing at the command line and having it do one thing at a time, when it's looping through something, it won't automatically, it'll do it behind the scenes, but it won't automatically print to your console what it's doing. So if you don't tell it to print out the results of this, it's looping through and doing the calculations, but just not showing you the results of it. And so what you want it to do, you're using this paste command. So we could just say paste, or I'm sorry, the print command, not the paste command. You could just use print square root of I, and that would just pop out the value of the square root of I. Which if you, in this simple example, if you know what you're doing, that would be fine, because you know what you're asking it to do, and it's easy for you to keep track of. But the reason I've made it more complicated is to show you some other commands, but also because many times you might not remember, there may be multiple stages in what you're trying to do, and it would be helpful to have it print more than once. So we're doing something slightly more complicated, where we're asking it to print two different things. So what we want it to print is we want to know what the square root, what it is we're having it print. So we want it to paste together two things. So the paste command, we're going to have it always print this text, the square root of I is, and then we're going to have it paste what the actual square root is, and then print out those two things together. We also want to know what I is, and so here we're printing the pasted command of I equals, and then the value of I. So every time we loop through this, it should print out I equals, and then the value of I, and then it should print out the square root of I is this. So go ahead and run that, and hopefully it will work. So now we have this nice informative output telling us exactly what it is that we're trying to do. It's easy to keep straight which of these two things go together. Okay. Would anyone else like me to try to explain that differently, or questions about what it just did? Pretty straightforward. Okay. The next way to do this is to use something called the if-else test. And this is when you're telling R to do one thing if a particular condition is met, and to do something else if another condition is met. So in your R console, if you do question mark if else, it'll pop up this description. And so you see in this command, the first part, you're telling it the test you want it to run. This should return something that's true or false. It should be a logical test. And then if the condition is met, you tell it here what you want it to do. And if the condition is not met, then you tell it under that what to do. So over here, first, in this case, we're now assigning to x the values 1 through 10. And we are saying, we're using this command, and our test is if x is greater than 5, print the word yes. And if x is not greater than 5, print the word no. And then we're assigning all of that to this new vector called number test. So when we run that, we're getting no's for the first ones. The first 5 values of x are less than 5, so it's going to print out what was told to print out in the no condition. And after that is the value of yes. So this is really useful for a variety of different things. I think I have in the code later on when we're doing the visualizations, if you want to color things certain ways, so you're doing a correlation plot and you want the dot on that to take on one color if the survey subject is male and another color if female, the survey subject is female. It can be really useful to create new vectors that meet certain conditions, like that. Still no questions. All right. A third way to do this is using something called the while command. And the while command is saying you should continue to do the things in this loop as long as this particular condition is met. So this is what was used above when we were trying to create this new variable in our macro data set. So we wanted to create this variable called US conflict, and we want to capture the years when the US was engaged in the Vietnam War, and I guess we were just saying that's every year in this data set that's less than or equal to 1975. So there are certainly other ways to do this. Like most things in R, there are 6 different ways to do whatever it is you want to do, but here's a new way to do it. So the first thing is you create this new variable, and instead of filling it with NAs, you're just going to fill it all with zeros. And you just do some visual checks to make sure your new variable created correctly. And now you want to change that variable to a 1 for every year in this data set, or every row in this data set that meets the condition where the year variable is 1975 or less. And so you're going to specify these conditions, and R is going to keep going and going and going as long as the condition is met. And so what we're first going to set our indicator variable. We're going to set it to 1. And then here are the conditions. So while this value of I is less than or equal to the number of rows in our data set, we want it to do these things. So now we're using this if condition. So if the value of the year variable in the ith position for our value of I, if that is less than 1975, we want to replace that value with a 1. And at the end of doing this test, at the end of doing this while test, we then want to add 1 to our value of I. This is our counter variable. We're essentially counting up to keep it going. And then it will repeat again. So as long as this condition is met, it's going to check to see if the year in that particular observation is 1975 or less. If it passes the test, it'll fill that with a value of 1. Then it'll add 1 to our indicator variable, and then it'll check the test again and keep running again and again and again. Now, it's important when you're writing these kinds of loops to not make them an infinite loop. So if you set something that doesn't ever stop, it'll just keep on plugging, just go, go, go. And so here, this is why you have it as a concrete. There's going to be a point at which I is no longer less than or equal to the number of rows in macro. So if you check, if you do n-row macro, that value is 350. So when you increment up and you add, when I equals 350, and you add 1 to that value, the next time it checks that test, it's going to fail the test, and that's going to end the loop. And then you're done. So if you run these checks up here, if you check all of these things, and then run your loop, and now check the summary. Again, you'll see that this US conflict variable has now changed and that it's replaced it. You could also do table macro. And now you see that there were 140 instances in this data set in which our condition was met, that the year was less than 1975. Yes?
What is the significance of the line breaks?
Of the what?
The line breaks.
Just to keep it separate in your mind. So if you use a nice text editor program like Sublime or Aquamax or whatever, it'll color code your commands and your loops and your objects in different ways. But if you're using a plain text editor program like this, it just helps keep track of what sections go together. That's different in different languages. Isn't it true in Python, spaces and tabs take on other, is that true?
Yeah.
That's true. So,
Python just uses like indentation.
okay. Yeah, so it's not, that doesn't tend to be a problem in R, but there's no like standard way to do it, it's just to make it look nicer.
So if you were just typing that command in, you wouldn't put any spaces, like where there are line breaks, it would just be continuous.
Interesting question. You might need the line breaks for some parts of the loop. You could try taking this out and taking out the spaces and seeing if it still works. Between lines of, I'm not sure. I've always learned it like this, and so I just keep replicating it. I'm actually not sure what happens if you try to condense the code.
Okay.
All right, please speak up if this is not, I'm really happy to go through it again. All right, so one of the times it's most helpful to be able to loop is when you are trying to merge together different data sets, match together different data sets. There are ways to do this without looping, and again, looping can be a really inefficient way to do it, but it can also work if you're dealing with small data sets. So in this context, merging and matching mean the same general idea. You have two different data sets, and you want to bring information from two different data sets together, so that you're attaching information from one data set into your observations in the other data set based on some sort of identification variable. I put the link in there if you want to read about merging, the merge command. Again, this is an awful explanation. I was always taught to use match as opposed to merge. I think it's because there are easier ways to mess things up in merge, and match, I think it's supposed to be harder to mess things up, but I'm not sure about that. I know several people who prefer to use the merge command, so if you want to look at using that as opposed to the match command, have at it. But I'm going to talk about matching just because that's what I tend to use. So we're going to go back to this occupational data set, the prestige data set. And let's say that you wanted to add in some other information about the averages for that kind of occupation. So there's a variable in there for type. We have these three different professional, white collar, blue collar, different type jobs. The other times you might want to do this, or any time you would have a need for, if you have survey data at an individual level, but there's some aggregate variable that's important that you want to include in your analysis. So you've got peoples and states, and you want to know how competitive the election was in the state. You've got newspaper articles in newspapers, and you want to know something about the characteristics of the newspaper in which it was printed. I don't know, are there any data examples that would be relevant? No. 8 characteristics in a country, and you want something, I don't know, whatever the case may be. So the first thing for this is just that I wanted to create this other data set to give you an example of. And so all of this command up here is just creating this secondary data set that we're going to use to match in some new data. So the first thing I did was I created a vector with our 3 different types of jobs. And then the second thing is I wanted the prestige value for these different categories of jobs. And so this syntax is looks really complicated, but it's not all that complicated. The first thing is the core of it, we are trying to get the mean prestige value, but we only want the mean prestige value for the cases in which the occupational type is professional. So we're going to use brackets here. We're taking the mean of our variable, but only the subset of that variable that meet this particular condition, that meet the condition that type equals professional. And then we're just doing that 3 times. So we're calculating the mean for the professional type, the mean for the white collar type, and the mean for the blue collar type. And we have the C command here, and the C command is the one that you're stringing together 3 things. And then a new command in front of that is the round command. So if you take just one piece of this and look at mean prestige, if you look at that, that gives you the value, but it's longer than we want. I want nice short vectors here. So if we do all of this, and then we get our nice, our occupation type average prestige values. So we're doing the same exact thing here, but now with just the proportion women in a particular occupational class and the average education level. And now we are combining them. We are row binding these guys together. And again, this is not the most efficient way to do it, but I wanted to show you another command. So we're row binding these together, but this doesn't look in the direction we want. What we actually want are 3 different categories now, our professional, white collar, and blue collar. We actually want this table transposed, and the transpose command is T, so if you look in there. So if you just do that little chunk of it, it's now flipping it the way we want. But one of the things I talked about on the first day was that there are different properties of different kinds of objects. And in this instance, we want to be matching together 2 different data frames. So by wrapping it in this as data frame, it allows there to be different type of vectors in the same object. So as opposed to up here, are thinking that all of these things are characters, presumably. It's now allowing a mix of numeric and character variables. Okay, so we now have this data with our 3 types of occupations and the information there. And looking at the head of our prestige data, this is the variable or the data set where each row in here is a different job, and it tells you what the type of this job is. Okay, so the match command, the goal is that we want to bring in all of the information about the average occupational characteristics from this data set, and we want to match it in for each row in our other data set where we are matching on the type of occupation. So this is a one-to-many match, I think, or a many-to-one, right, where you've got single information here that you're going to match multiple times into this data set over here. And so what do you want to do? So you have the variable that links these 2 together is called type in the prestige data set and octype in the other data set. And this match command is going to produce a vector of the length of the first vector here that you put in, but it's going to contain the position number from this other variable. So if you just run this single command and look what gets spit back at you, it's full of 1s, 2s, 3s, and NAs. And so what this is saying, so we're looking at this variable. Let me do that one actually. So it's looking at this variable in our data set, the type data set, and it's saying in what row in this other data set does it belong. So all of the professional ones get a value of 1. The blue collar ones get a value of 2, and the ones that are missing get an NA value. So it's creating this kind of correspondence variable. And so then what you want to do, our goal then, is to bring this information over. And this matching command allows you to know how to put it in, essentially. So what we're going to be doing is we're going to be looping through each of the variables in our occupational data data set, going through and saying, move the information in that variable over in the order that you've established on this match command. So here's our match command. This is telling it the row order. And we're saying take that from our occupational data. So take the 1, 2, or 3, take that row over. And this is our indexing variable for I. So this is telling you the column from the occupational data that you want. So take that over and fill that in to our prestige data set. What is dim prestige bracket 2? What does that give us? This command that I've highlighted right here. What's the dim variable give us, or dim command give us? Here's the thing over here. Dimensions, yes? And what's the second position in dimensions? It gives you first the number of rows, and second the number of columns. So the dimension here is the current number of columns, and then it's adding 1 to it. So it's saying put it in the next available column. And then there's the comma here. So we're leaving the rows vacant. There's nothing in front of that comma. And we're just having it match in the data into this new column position. And then we're having it move the names over as well. So we're taking whatever value our I takes on, we're saying take that name from this other data set and apply it to the position, the newest position in the prestige data set. And then what you're doing is you're looping through. So we've got our for command here. And so we want to loop through, we're using our index variable I, and we want to start it at I with a value of 2, because our first column of interest, the first data we want to move over, is in the second column. And we want to move through all the variables to the very last column in the occupational data set. So that, again, we use this dim 2 here. And then you have the curly Q brackets. So it's going to loop through. So how many times is this loop going to go through? How many different iterations, how many pass-throughs of this loop are we going to do? How many different variables are we moving over? 2. We're starting at number 2, but how many total are we going to be doing? We're going to be doing 3, right? So the first time we pass through, I is going to take on a value of 2, and it's going to move the information over from column 2. Then our I's, once it finishes the loop, then I is going to increment up to 3. So then we'll be moving information from the third column over. And then I is going to increment to 4, and we'll be moving the fourth column over. And every time, it's going to move the information over in the order that we want. The order in our prestige data set based on the way the type variable shows up. So if you run that, and then look, you've now added in these 3 new variables. And they're all the same because all the first set are all professional jobs. But if you look at these, it's going to tell you the number of counts in each of these categories. Okay, what can I explain again that would be helpful? Any bit of this? In the past, students have gotten very, very confused. All right, we'll do some spot checks then. What does this second line, so let's say that I were in the loop where we're in the loop where I has taken on a value of 3. So what does that mean? What name are we gonna pull over? So we've got our occupational data set over here. When I takes on a value of 3, what is this gonna be?
Blue collar, white collar.
So the name.
Oh, professional white collar, blue collar.
So that's the row number. But what does our names vector for occ data look like? You can type it in. What are the names, the vector, this thing called names occ data, what does that look like?
OC prestige average, OC women average OC.
Yeah, so occ
Education
data,
average.
the vector names occ data has 4 elements in it. It has occ type, occ prestige average, occ women average, and occ education average. So up here, it's going to take the value of I, it's going to take the ith position in that vector. So when I takes on the value of 3, it's going to take the 3rd position in that names vector. So if you look at that, and you look at the 3rd, it's going to take over that name. It's going to move the name of that variable over into the appropriate place. Okay? What about here? How does this match work? Someone try to describe what that match command is doing. So I can put it in again. So the first thing is there anything about that match command, what I've highlighted right here, is there anything about that changes each time we go through the loop? So just the part that's highlighted right now. Is there anything about that changes depending on what iteration of the loop we're going through? No, why not?
It doesn't have any relation, it doesn't have I anywhere in it.
It's not referencing anything, it's not using I to point to anything. So this is essentially fixed. If we do just this bit, remember this is this fixed ordering. And so what do these numbers represent? So so we've just created this new vector. What is the length of this vector? Relevant to the other things we've been talking about, what is the length of that vector? What is it the same as? We've got 2 different data sets floating around. We've got the data set we're trying to match data into, and the data set we're pulling from.
It's the same as the length for the first data set.
Same as the length, which part of the length? Is it the number of rows or the number of columns? The number of rows. So if you look at DIM Prestige, that's 102 rows. And if you look at the length of this vector that we've created, it should also be 102. So there's one position in that vector for every row in the data set that we're matching into. And what do all the 1s and 2s and 3s refer to? The type, but specifically, what is the reference for the type?
I'm not sure what you mean, but up there in Octave, like it's telling it which of those rows, like 1, 2, or 3, to take the value from.
Exactly. So the 1s and 2s and 3s are saying, look in this row of Occ data to pull the appropriate information. So it's an index telling it where to pull from, and then it's got every row in the data set we're matching into has been assigned a reference position, essentially. Okay, so we're taking this. This is now a vector full of 1, 2s, or 3s up here. And so it's moving the corresponding value for I. And remember, I is telling us what column to pull from. So it's essentially telling us where to pull the data from Occ data, and then you're going to drop it in this new last column position in the Prestige data set. So let's say that there was another column of information in the Occ data set, and that we had occupational prestige average, occupational women average, occupational education average, and occupational income average. What about our loop would need to change if our Occ data now had 5 columns, that had an extra column over here? It's a bit of a trick question. Is there anything that would need to change about our code if there were additional variables in our occupational data set? No. Sasha, why not?
Because you're referencing the dimensions of Occ data in the first line.
Yep. So what we're telling it here is no matter how many columns there are, we want you to go from the second column, that column where we have the information we want, to the end of the data set to pull over all of the different columns that you want. And so to the degree possible when you're coding, you always want to code in this way. You want to code so that your code is flexible, and that if you make changes to things, you don't have to rewrite your code. That you've set it up so that it's always going to pull, in this case, it's always going to pull all of the variables that you want. And same thing here is also flexible for the number of rows in the data set. It would change the length of this match command if you had more rows in your Prestige data set. Then that match command would create a longer vector. But this is coded in a way to be flexible for the however many rows you have in your Prestige data set. Okay. I'm not entirely convinced that I've explained this clearly, but we're going to move forward. And when you discover words for the things that you don't understand, let me know, and I will explain it again. Okay, the next time that it can be really useful to write a loop is if you are trying to extract out some summary information about your data set. So in this case, so say you've got a new data set, as sort of best practice, you've looked through, you've read it in cleanly, and you now want to know just some summary descriptive information for all the different variables in your data set. One thing you could do is over and over and over again type, mean data, variable 1, and calculate that out. And then you could cut and paste and put that number in an Excel table. You could calculate standard deviation. That would be incredibly labor intensive, right? You could do it. You have the tools so far to do it. But it would be very exhausting to do it that way. So what I'm doing here is showing you how to create a new object, a new table object, that you're then going to fill in with all of the summary statistic information that you care about for the variables in your data set. So the first thing you do is you set up this placeholder matrix to receive all of the information you're going to generate. And so here we're going to call it summary stat. We're creating a matrix. We want it to be filled with NAs. We want it to have 4 rows, and we want it to have 5 columns. So we have 4 variables that we're interested in this macro data set: GDP, unemployment, capital mobility, and trade. So each row in this placeholder data set is going to be filled with information for a particular variable. And we have 5 statistics that we care about. We want the mean or proportion, standard deviation, the minimum value, the maximum value, and the number of observations for that variable. So we set up this placeholder object. Yeah?
What is the as data frame command mean again?
It's converting the matrix type object to a data frame type object, and that allows us to assign names to the different columns in the object.
Okay.
Yep. So the next thing we do then is assign those names. So we use the C command, and these are the different names. So if you run those, and now you have it print out summary stat. You've got this table looking thing full of NAs. We now know what statistics are going to go in there. But now we want to know the variables. So I'm going to assign the row names for our object to be the names of the variables from our data set that we want. So if you run that next line of code, so we now have this placeholder data set. Every row is a different variable. Every column is going to be a statistic that we want for each of those variables. So now what we need to do is fill all of this with information. So we could do this by hand. So each of these here, these are the 5 commands for the information we might want. So we could do it focusing first just on our GDP variable. We're filling everything into the first row in our summary stat table, and then we're just putting into the appropriate column what we want. So you could cut and paste this, you could change the row, and you could change the variable, and just do that again and again and again. For our 4 variable data set, not a big deal to cut and paste. But if you have a larger data set, you're changing defined elements again and again and again. So this is the perfect thing to loop. Because the things we want to loop are the variable that we select to summarize and the row in the data set in which we want to put it. So here you see that we're potentially filling it in by variable name. We've got macro GDP here. Another thing to be able to do the same exact thing, as opposed to calling the variable by name, we could call the variable by its column position. So if we have it print out, so the first 10 values of macro GDP, and the first 10 values of the third column of the macro data set, it's the exact same thing. So this code here now sets it up so that we've got the same thing, but now instead of calling macro GDP, we're calling macro GDP by its column position. And so here's where you make the leap in order to fill the loop. So we have our loop, we have our 4, and then we have our squiggles here. And we are looping through. So our variables are found from our macro data set that we want to summarize, are found in columns 3 through 6. And so we want I, we're going to pull the ith column in each loop. And then here it says I minus 2. And so I is going to change. And the reason we do this is because we're starting with number 3. But we want things to move into the first row. And so this it'll iterate in the same way, it's just iterating on a different order. So one way you can do this, instead of looping through I, you can test a loop by first assigning I just to the value of 1. And then you can run all the meat of your loop. And it won't work for you. Why is it not?
Should we start at 3?
Yeah.
Yes, thank you. So instead of setting I at 1, you set I at something reasonable. And now you do it. Thank you, that's exactly what it was. It wouldn't let me do it because the first column, country, is not something that is amenable to having the mean of. So if you print that out, you see now that it's plugged in all the values for GDP. And if you want to check it, you can do mean macro GDP, and lo and behold, you get the same value there. So now you wrap it in your loop, and you're having it iterate through each column, 3 through 6. And lo and behold, you get that. Now in this case, I've shown here you might want to round this so that it looks a little bit nicer. And then in terms of exporting it out, one of the things you can do, there's a, you have to first install the package, but I have the Xtable package installed, so I just need to call it. So one option when it's nice and clean like this is you can just cut and paste and put something like that into Excel. If any of you are interested in getting into nicer ways to present your results, you can use LaTeX, and this outputs, it's got a bunch of other jargon in it, but this other software program knows how to read that to make it look like a nice clean table. Okay. Anything to clarify? Okay, the only other extension I wanted to do on that, so in the case I just showed you, the variables we cared about were in this nice sequential order, 3, 4, 5, 6. But it might be the case, especially if you have a large data set with a bunch of different types of variables, that you have a sequence that's not nice and chronological like that. And so in that case, what you do is you create a vector object of the columns that you do care about. And then you add in this extra step, where instead of I referring to the column position, I refers to a position within your vector, and then that position within your vector refers to the column number that you're trying to call. So we've replaced notice here that we're calling macro I, so we're calling a column position with our I variable. And we're just here replacing that with vector I. So the first thing I is going to do is refer to the position within this vector. That's going to give us a column number we want, and so then it'll replace vec I with the column number in the ith position. Does that make sense? Yeah. Okay. All right. So I want you guys to get some practice with this. So let's take about 10 minutes to have you open up this silly data exercise. So this data set is the one I emailed out to you. This is based on the results of the survey you took on Qualtrics. And get through, so you do a couple of quick things here, and then you run the summary table here. The way this summary table works is I've given you the framework for it, but there are parts of it that are missing, and you need to look through it and figure out what parts in this second part here that you need to fill in to make it work. Alright, so take about 10 minutes to poke around with this. Yeah, Manu?
Just like an unrelated question, what is a crayon mirror? It's like something that's kind of what I've been using.
A crayon meter?
Mirror.
Crayon mirror. I don't know I don't know actually what it is, but what it refers to is, there are different centers around the country where R is posted. I don't know, it's where, you're pushing my limits here, man. It's basically these packages that you download or updates to R. It's telling it where to look to be able to pull that from.
Okay.
So you always want to set your mirror at a geographic location close to you.
Okay.
Yeah, if you do it, if you do package manager, first time you, no, not that, package installer maybe. It'll tell you, first time you do this, it's gonna ask you where you want to set your crayon mirror to.
Okay.
But I have no idea what it actually is.
Okay.
Not a computer scientist, sorry. Alright, so please flag me over when you get stuck on something and work with each other as well. And we will pick up with the visualization stuff at about 5:35.